Welcome back welcome back to Made Up of Wires. Merry Christmas. A rough start to the stream. Oh, and I see that my webpage, not mine, but the webpage I usually start with is not loaded. There it is. Welcome to Made Up of Wires. Merry Christmas. We are decompiling Castlevania Symphony of the Night. My 33.6K modem is apparently kicking the bucket, and I probably need to upgrade to something a little faster. I can't remember all the names for all the protocols or enhancements to get additional speed. But anyway, we're back up and things are running, and the signal looks much better. But of course, Safari is just going to drop images when whenever it wants to. So we had been decompiling, and of course now an ad's going to start too. Oh, great! Ad start in 4 minutes. We had been decompiling the Sword Familiar. Look at this. How terrible. Come on, Safari. Do your thing. We had been decompiling the Sword Familiar, and I think I'm going to hold off on doing any more of that on the stream, because most of that is just going to take a little bit more work. I have some PRs out, and I'm kind of slowly pushing those out, and we'll see where that shakes out as those get merged in. And then yesterday we looked a little bit at N0, which is mostly done. I think there's one method or one function left there. N01 was the next kind of up and coming overlay that had things to do. Oh, this is rough. This is a rough time we're having technology. So let's look at N01, which is the outer wall. What was N00? Marble Gallery. I'm not sure where the naming, some of the naming is pretty obvious, but the NOs, not sure what those are, what they're in reference to, but we don't have to know, we just have to decompile. So let's go and look for those and see what we can find in the N01 stage. So we're going to look at non-matching and look for files. I'm going to go backwards. Nope. Sort the right way by number. Yeah, there we go. So there's definitely some pretty big things. Many of these, we really only care about the things in unknown segments, so I'm going to prep for those. Everything else is duplicate, and we can look at that if people in chat or anybody is interested in duplicates. I think we've looked at that before, and how to integrate some of the duplicated functions and data. I'm going to pick one just right in the middle. I don't remember what we took yesterday. I do remember, though, that yesterday there was some... Here's the one that I'd opened yesterday. We looked at 4.8c. There was something curious about that. I don't recall what it was, though. So I'm not going to look at 4.8c. Let's take the next biggest one, which is B9c. I'll create the scratch, and then I will come back and do a little research on where this might be getting called, if it's how integral, I guess it is, to other things, and we could try to get a sense of what this function is and what it's for. So first I'm going to look to see if anything has been decompiled that has references to this function yet. I haven't looked at outer wall at all. It is actually kind of a nice section of the game to have decompiled. There's some interesting things like when does the smoke effect or the fog effect occur? I think that's after defeating Doppelganger, if I'm not mistaken. Maybe I am mistaken. But that kind of changes the atmosphere of that section. There's the elevator, obviously, which is interesting. So there is some pretty iconic stuff in the outer wall that that'll be fun to see if we get to any of it. All right, so I'm going to look at anything there. Oh, and okay, I thought playback had stopped. Background music. I do need to look at that. So, oh, this is interesting. So we do have a reference in the initial data of this function, or for this function, and I'm guessing that, oh, it's not, it is one of the entity update functions. So this looks like it's a unique entity in the outer wall. And so we can kind of go through and see what the offset is into this function to try to determine or to give it a number. But I'm not interested in doing that yet. So all we know right now is that this is some entity. It might be worth doing, actually, because if we know what entity ID offset this is, then we can find other things that are creating that entity, and that might help determine what this is. So off screen, I'm taking the offset of this array, or whatever struct this is, the starting point of that, and then I'm going to subtract the starting point of our entity update array, and then dividing that by 4, because each of the pointers is 4 bytes. And this looks to me like it is so we have 94 of these. So the last one's going to have index 93. So this looks like 86. And 86 is going to be 5.6 in hex. So I'm going to quickly grep for that and see if there are any obvious matches. So we want to find either immediate values of hex or something that's probably filter out all of these offset variables. So this here, function 54, oh, skeleton ape. Let's see what skeleton ape is doing. I don't know that we've decompiled anything else. That would have skeleton ape code. So what I'm assuming, and this might not be correct, but it is going to, yeah, A0. So this, thinking about what the skeleton ape does and how the skeleton ape works, it's possible that this is like, what does he do? He throws a barrel. Does he go up in flames? I can't remember if he does or not. We can look at the wiki and see if they have anything on the skeleton ape that's worth looking at. Do you have any animation from Soten? No, I was hoping. A lot of times there are GIFs here that. But I don't see anything. Okay, so what is going on in? Of course, maybe I could show you what I was looking at. There is Skeleton Ape, and I don't see anything specifically regarding the animation or anything visual really to show there. So we, in this area around skeleton, or in the this particular skeleton ape function, we're at this label in the switch. Actually, this label is being used a couple different places and may just be like a go-to. This is actually a relatively small function as well. Maybe we'll start here and then go on to the one that we were looking at. And that might give us some hints. This one that I originally pulled, we are creating the next entity down as well. But I'm going to start a new one, and these appear to be related. I'm doing the wrong thing. Right. If you haven't watched a stream before and are unfamiliar with the tooling we're using, we use decomp.me, which is a collaborative decompilation editor. It contains a bunch of the compilers for SDKs for a variety of systems, and allows you, it has some tools for doing some automated decompilation, and sometimes that works out pretty well. In other cases, there's a lot of work to be done afterwards. I think we have everything that's necessary here. So there's a little bit of complexity, but not a ton. So I'm going to go through and clean this up, and then we'll get going. I don't know why I don't have animate entity in my context, because this seems to come up quite a bit. So first I'm going to get signatures. Often when the assembly is pulled and put into decomp.me, the initial decompile is done, but we don't get something that can compile. And I think that's, some of it's due to M2C, not M2C is the decompiler, not being able to get all the function signatures or figure all those out. And I'm not. Some of it's due to data types that it doesn't know. So off screen, I am just looking for I'm just looking for the signature and I'm not seeing it. is this? So we have a couple different signatures for animate entity depending on the version. It looks like the Saturn has a different signature. And it's probably just, or it may be a difference in what the function does, and maybe it shouldn't be named the same thing. Create entity from entity is similar. One of the reasons these don't show up necessarily in the context is, oh, here's our explosion. So what we have is that other function is not the explosion. One of the reasons these don't necessarily show up in the pre-generated context is sometimes the code depends on them being declared, and other times it depends on them not being declared. This func_us function may not be decompiled yet, so we'll have to take a guess on what these arguments are. So the second argument is unknown. Let's assume a void return type for now, and the void argument should be fine, and then this unknown collision function is the last one. These are all things that have been identified previously. So now we have a few globals that need to be figured out depending on, since we have these, actually, we have these signatures now, it's probably worth putting these into the context minus this one, which is still unknown, and then decompiling again, running the automated decompiler. And that should give us some additional types for these variables that the type was unknown before. And then this last one, we have, we can tell the type based on the scale of whatever's being added to that pointer. So it looks like probably a sine 16 being applied to position X and position Y. That makes the most sense. A little strange that it looks like the Y is coming from the index before, but possibly not. We'll see how that shakes out. I'm going to assume that's an array because it's being indexed. This unknown collision function, I want to look at the arguments for that quickly. Takes a pointer to 16-bit values. I'm going to assume that that is an array as well, and then we won't have to take a reference to that. That's possibly a bad assumption, but we'll see. And what else is it upset about? So we have a void pointer, and let's see if we can determine what that is in context. It's this temp S1. So we're getting something from the entity extension, which is related to this entity, which we don't necessarily know what it is. Something related to the skeleton ape. But we can't necessarily be sure. yet. We're accessing offsets 2C and 26, both hex, and 14. So if 14 is facing left, then my assumption is that this is going to be a entity pointer, and we can load up that struct and see what is at offset 14. And offset 14 is facing left. And then just to review what 26 is, entity ID and step. And 26 being an entity ID, this is in the range of other entities, 53. And the step, in this case, we have 4 here, but a step of 7 is not necessarily unreasonable. So we're looking at an entity extension where basically this is the second element in that entity extension. So I think it's worth, is it worth starting there? Yeah, probably. Let's look for the entity extension union. So in this union, we have a ton of options. What I think I'm going to do is get rid of well, first I'll look for skeleton ape by spelling properly. There's skeleton, blood skeleton. I don't see anything related to the skeleton ape. Basically, I'm just going to get rid of all of these extension structs, and even the illegal one. And then we can start fresh, and the decompiler will only choose our structure. So we have something at 0, offset 0 in this structure. We don't know what that is yet, so we'll just put a placeholder there. And then it appears that the next thing there is a entity pointer. We don't know what it is yet, though. So I'm just going to call it unknown entity, and we don't know what this is yet either. So I'll call it unknown skeleton ape. Somebody has come through already and identified this as something related to the skeleton ape. And we don't want. So now when we're doing the decompilation, and looks like at some point I had an error. I don't think we have entity yet, so we need to use a placeholder. We don't have the type def yet. So now when M2C comes through, it's going to identify that one type, and it's going to say, oh, I know what this is, because I only have one choice for this union, and that field aligns with that one choice. And so we force that into choosing the field that we want. And let's see what else there is. There may be other things in here that that we need to deal with. Oh, and drat, by doing that, I'm going to just take this and below. And I know I got rid of some. Nobody's checking me. Chat, where are you? Nobody's checking me. I got rid of some of the references earlier. And I think I can do that again. And let's see where we are on decompilation. Or compilation, I should say. So we have something at 7C that is missing. And 7C is going to be actually the first field in the entity extension. So that's a pretty easy one to identify. Let's see where that is being used on 56 and 58. Temp V0. Basically, we're decrementing this with a floor of 0. That makes me think it's a 32-bit value. We'll see what the size is later. I really want to put an E. So we have our entity ape extension, and we're just going to call that unknown 0 for now. It is being cast as a sine 16. That's a good indication that it is sine 16 and not a 32-bit value. So I will change that. And that means then that there is some additional padding that we need, and we don't have a reference to anything there yet, so we'll just make it anonymous. All right, so still have some question marks I didn't undo far enough. I'm going to undo until I get those back. I had resolved all those. Copy, and then redo. We still have an unknown 7C. I'll just do a find and replace for those. And then 109. This is going to be array access, and so we can get rid of most of this arithmetic and get rid of the scale as well. What I don't know is, I think the 4 would not be scaled yet, so that is fine. What the meaning of that, though, is I don't know yet. So on 110, it says that I have a missing paren, and I do. Still have one. Where is it? I'm coming to terms with getting old and having to probably get reading glasses soon, which is not ideal. So sometimes M2C can't figure out stack pointers. And so in this case, there is something at offset 10 on the stack, and it doesn't know what. from context, this is a collider. And so it should know that it's a collider, but I don't know why it doesn't pull the first field. It should know that it's a struct. So it can't do math directly with it. So that's going to be the effects field of the collider. And now we're compiling. And at about 83%. I've been meaning to look at whether or not any of the like Copilot or anything like that. Some other people in chat or in Discord have started to look at this as well. Whether there's Copilot, for example, if it's trained on this repo, is a better decompiler than M2C? I don't know what the answer to that is. All right, so SP10, these are all generated variable names. I'm going to start to rename those and start cleaning up as much as I can. So temp S1 is being used for, in this case, is the S1 register. It's being used to store the pointer to this unknown entity. It's difficult to do a find and replace there because of the way that's written. So I'll go down here first. There is. This can become a minus equals. There is, it's possible that this velocity y is being read before the condition. I don't necessarily like to make that assumption because this GCC doesn't necessarily know if unknown collision is modifying this reference. I am going to make this change. Actually, I'll make it a variable first. So temp s1 underscore 2, we can name velocity x, and hopefully we can get rid of that, or velocity y, I'm sorry. Hopefully we can get rid of that later. And then we're doing some work down here. This does not seem to be necessary before this condition. We're looking to see if we've fallen, basically overflowed. Being less than 7 FFF. So this is the max for assigned 16. I think that this is just based on... This is the code that GCC generates for the division. I don't think it needs to be explicit, but we can look at line 85 and see if that is needed to be done. Oh, and it looks like, yeah, it looks like it does need to be done. I'm a little surprised. Let's look at this, branch not equal to 0. I guess what this is doing is if, how would that come to be? I guess the velocity could be negative, so headed down. And then we divide by 2. Yeah, I'm not quite sure. This check here becomes a plus plus, and whether or not it's inline or not, we'd have to refer to the PSP version. After I get rid of some of these, we'll start dealing with the go-tos. I think this particular one can be dealt with by making this an else, and then this will fall through. These usually work out to be assignments on either side of a condition. These large hex values are fixed point SOTN variables as opposed to fixed point PlayStation variables. SOTN uses fixed point values that are split between 16 bits for the whole number and 16 bits for the fraction. I wanted to find this block 37. This looks like a GCC optimization, and we can just put that there. And actually looking a little closer at the condition, we'll change this to a greater than or equal to, and now we can get rid of this else. And I think that's the only reference to that label, so we can get rid of that as well. So now I'm going to go down and do a little bit more cleanup. What I want to do here is unwind some of these as well. So we have cases where a case in this switch is returning. And what do we do after the switch? We return. So for consistency, making this a break makes more sense. And this case 1, even though it's the same as this code inside of this particular condition, it makes sense to duplicate that because of how simple it is. So the default we can get rid of. This return, it looks like this is a... Oh, this was a fall through, but I need to be careful there. That fall through was just going to return. None of this necessarily improves our match, but is more likely right than not. And mostly, I mean, this is just simplifying, and as it gets simpler, and looks more like code that a human would write, the match gets closer usually as well. And I've not really looked yet at where things are different. That will come, but most of this is just cleaning up right now. I want to see if this temp v0_3 is being used, and it looks like not. So this is kind of an interesting addition here. So this is taking the index to entity 224 and adding 1780. We'll have to do some math to figure out what that offset is. So 1780 x entity is size BC, and I get that as 32 later. So 32 after 224. I'm assuming this 224 is decimal. So I'm going to say that's 256. And we can check the offset there. 107 is where this is. See if that looks correct. Unfortunately, we're not going to be able to check that directly. Oh, interesting. So this, it does look like it is taking... I'm not sure what's at 224, but it does look like it is doing the addition.
The end is in the beginning, and yet you go on. Prepare to die in Spitalfield.
Yeah, I'm not sure what's going on there. It's possibly because... Okay. What I think is happening is GCC has decided I'm grabbing entity, and it looks like my math was off. So I'll have to figure out why that is. Yeah, I'm not sure where that difference is coming from. So it's GCC saying I'm calculating the offset of 224 into entities. And now I have another entity that I'm going to read, and I'll just calculate the difference between them. In this case, 1780 versus 224. I'm not sure though why. G entities is an array of entities. I didn't think that there was padding necessarily, but anything's possible, I assume. But oh. This is my fault. because I got rid of everything in the union, my union is too small. And so I need to make it large enough to, and I'll do that with the illegal. Let me find where that was. Basically, the illegal structure is just there to pad it to the correct size. Why don't I have it here either? So I'm searching the wrong place. Placeholder is its name. There we go. Now we have the 1780 offset. It's pretty common to make mistakes, so it's always good to be able to correct those as they come up. Now I think I'm going to go... I think all of the go-tos and everything like that has been resolved. Oh, I will give this a name. We'll call this one new entity as well. I guess I didn't rename that originally. I'll look at what these other ones are. That one doesn't exist anymore. Call that new entity as well. Here we have a loop. We can fix that loop. Let's create an I variable. And our I is going to be less than 4. And now we have to be somewhat careful because the increment is happening early, and so if there is a use of this variable anywhere, we want to know. The other thing that's interesting is that this is being possibly incremented twice. Once in the loop and then once in this logic. So now I'm going to step through kind of top to bottom and see where differences are. R means that there's differences in the registers. Those will work themselves out as code becomes more correct, or types are chosen correctly. On 72 and 73, this is the first issue I see here. These offsets are wrong. And offset 84 for an entity is going to be at the last field in the struct. The extension struct. And because, for whatever reason, the decompiler chose B8, which is, I don't know why. It assumed that it's an entity and is casting that to a entity pointer, but that address is not going to have an entity pointer at it. So we don't want to do that. So we have to go through and pad. And I should actually rewrite this as a considering the offset that all these things are at. Was this B4 or B8? So we're all the way at the end of this. So we need a lot of padding. So we have to go all the way through the 8s, all the way through the 9s, all the way through the A's. And if I did this right, this last one will be B4. We don't know what that is yet, so I'll just call it unknown before and after. Oh, but oh, I read this wrong completely. It is actually 8-4 that we want, not B4. That's better. All right, so that is resolved, and we can keep going. It looks like happening again down here. So part of this is pointer arithmetic that M2C doesn't get correct. And that's, well, in this case it's not, it wasn't supposed to be using that pointer at all. We want this unknown 8-4 again. And we can say here greater than 2. Which is the same thing. But this is unsigned. So the signed less than immediate, sorry, not, what is the S for if not signed? Let's change that to an unsigned. The mnemonic in my head was, is source, but I always read it as signed. Good to know. So SLTIU source less than immediate unsigned. So making the field unsigned will make that instruction unsigned as well. There may be other issues up here then because we're doing the assignment should be fine because that's the same regardless of whether it's signed or unsigned. So I think that's fine. What we mostly need to be worried about is, I guess, if there are arithmetic operations that treat that differently. Then down on line 116 is where we first start getting some bigger differences. So this var A2, there may be one of two things happening here. Sometimes this indicates that, and I'm just going to clean this up. Sometimes this indicates that we're actually making a function call on both sides of this. And that makes the most sense to me. So we're going to do this function call, and GCC knows that it's going to have to read the position X regardless of what side of the branch this takes. So it's going to read that first, and then depending on the branch, do the addition or subtraction, and then unify the call. So let's get rid of a lot of that and see if that is what was expected, and it's not. It's okay. So often GCC will optimize that out. So instead, what I think is happening is we just need another variable for that argument, and it looks like it is a. I'm going to go with a sine 32, and we'll see if it is. So this is the x coordinate. So this is checking a collision at these. So the entity's current position plus or minus 16. So something in the front of this, depending on whether it's facing forward or not, or facing to the left or right. And so here there's a couple ways that this could be done. It could be this. It also could be a ternary in the line with the function call. It's possible that y is being taken out as well. There's actually a little bit more up here that looks like this should be a plus plus. Yeah, but not all is right. So I'm going to try to change this to a ternary. And we're... This was the wrong value facing left. So this isn't quite right still. This would probably be, I can do a couple more iterations with this. My impression, though, is that this is going to be easier to solve with the PSP version, and so it might be worth looking at that. Temp v04, rename rand. Actually, rand is a function call, I think, so I usually call it roll. Yeah, I'm debating whether or not it's worth looking at this closer. So, yeah, let's do it. So X and Y are being read first. That's how I'm reading this anyway. We have offset 2, offset 6 being loaded. So here's our load at 2, our load at 6. Possibly these are happening before the check. That seems unnecessary, and I would think that GCC would optimize that out. So I'm going to move those back. So we have this add 1. That's happening on line 115. That's fine. Actually, our loads are happening before that. Before that store. It's similar, but seems a little strange to me. What is missing from these is the shift left and shift right, and those are taking, and actually maybe that tells us that these should be signed 16s. Yeah, and we get those for free. That is how GCC casts 16-bit values to 32-bit values. And on the MetroWorks side, we'll see something different. We'll see the SEH instruction. That is an instruction that didn't exist on the original PlayStation, but does exist on the PSP. So let's see if that does anything for us. Not quite. I'm not sure exactly what might be going on here, but pulling out the PSP version would make that much easier to solve. So I'm gonna wait on that until the PSP version can be loaded. Down in line 140, these should be the same indexes as above. I missed this. This should be I. Oops. I had to redo my my background music, and I took that out not because I don't like it, but I wouldn't have chosen it to begin with. But it's just noisy. So there's an addition here. +1 is happening early. And what I want to see is whether or not that affects this, and it does. So in this case, we need to increment I first. This is V0 being stored. Seems to be thrown away because it's overwritten immediately, and there's nothing that I see as reading it. I'm not sure what's going on there. I will defer to the PSP for that as well. We have another case down here where the value that's being incremented, maybe that's what it is, maybe I is only assigned 16. And so it does some, yeah, it does some funniness to shift left and right depending on whether it's a 32-bit value or not. And that gets pretty close. The immediate values I'm not worried about. So everything but this section around checking the collision looks like it matches. We're right at time though, so it is Christmas Eve and I want to spend time with my family. And I'm sure you do too. I do appreciate everybody who has shown up throughout the year. We're going to take Thursday off this week because it is Christmas and we have a lot of stuff to do. But there will be more decompiling just before New Year's. I guess we'll have a very special New Year's episode as well. If you want to know more about the Castlevania Symphony of the Night decompilation project, go to soten.z.dev to learn more. You'll find the progress on several of the overlays that we've been working on. Today we were looking a little bit at N01, which is the outer wall. I'm pretty excited about that and hope that we can get some stuff done there. I'm not driving the order that any of these overlays are being done. I did think it would be somewhat fun to have kind of the speed run route to Dracula, so we could have all of basically one path to endgame finished And so I might map that out and see what I would think that the next overlay should be. What I think ultimately doesn't matter. And we could work on whatever we want on the stream. Whether or not it gets merged back in at the moment will be another question. But that's all I have. Happy Merry Christmas, everybody. Happy holidays. As always, thank you for streaming, like, follow, subscribe, and I will see you all next week. Adios.